Hey, what's up, lads and ladies? Brad the Guitarologist here. Today's video, we're going to open this box and do some work. Looks well packaged, so I think it probably survived pretty good, is my guess. Let's do this. I'm not sure which way is up or down on this. Oop, something went right there. What was that? What the hell was that? That didn't sound good at all. The bell came off of the speaker. That's what's rattling around. Oh, this thing is beautiful. This thing is beautiful. Wow. Okay. New handle, I can see already. Model 66J. This thing is going to be cool. And yes, I believe this is a Guild. It would have originally had a Guild logo right there. The trapezoidal front grille. Audiovox, I think Audiovox made this amp. Actually, I was going by memory here, and what I meant to say was Multivox. Multivox was the parent company of the amp brand Premier, and apparently also did outsource jobs for brands like Marvel. Many of their amps had a distinctive trapezoidal grille, and their New York factory was suspiciously close to the Guild New York factory on Pearl Street, which they occupied until November 1956. In a 2010 Premier Guitar Magazine article on Guild amps, author Wally Marks writes, quote, "These first series master amps were made at Guild's factory on New York's Lower East Side. Rumors persist that Multivox, which was located nearby, made Guild amps, but this is most likely untrue. Hans Moost, author of the excellent Guild Guitar Book, states that former Guild employees remembered amplifiers being built at both the original New York City factory as well as the subsequent facility in Hoboken, New Jersey, using components supplied in part by Ampeg. This does not completely eliminate Multivox from the picture, however. If Guild used Ampeg components in New Jersey, it is entirely possible they used Multivox components while based in Manhattan." End quote. I happen to own the book written by Hans Moost on Guild, and he seems to be referencing a quote on page 14 of that book by plant manager Bob Bromberg, who states, quote, "We also had amps at the time. During the 50s, we had Ampeg punch out chassis and install tube holders. We would then wire the chassis ourselves," end quote. What the book also states on page 14 is that Bromberg left the Guild factory sometime in 1959, the year this amp was made. So it is at least possible he wouldn't have known about production changes to the 1959 amp lineup. Also notice Bromberg only addressed the chassis manufacturer, not the cabinetry. Guild was famous at the time for farming out portions of its manufacturing. For instance, it was not until 1962, a full 6 years after their move to New Jersey, that they finally hired a full-time in-house guitar finisher. Before that, they hired an outside company to come in at night and finish the guitars that were built during the day. While I'll concede it's interesting this amp has a swirl in the grill cloth, which is also something Ampegs at the time were featuring, other amp makers such as Sano, also based in New Jersey, were sporting similar swirly grill cloths at the same time. It seems likely the cloth was something being offered by a local supplier and multiple amp makers from the region were using it, maybe even sharing the same sales rep. It is my contention that at least the cabinet, if not the entire amplifier in our current 1959 example, was built by Multivox in New York. Here's a clip from a video I did several years back when researching the origins of another mysterious amplifier, which I think corroborates this suspicion. Okay, to aid in our investigation here a little bit, the owner did say in his letter that he had discovered this amp, which is a Marvel badged Model 25, and on the back especially, this is all pretty much the same, and we can see on a close-up the same paint scheme. So we've established that this amplifier that we have had a sister amplifier which was labeled Marvel. Now if we look at some other marvels. They kind of carry the same sort of trapezoidal shape here on the grill. Here's yet another one. The trapezoid is upside down on this one, and this looks like a little bit of an earlier one. But you see this sort of thing, very reminiscent of Premier amplifiers. You can see here this Premier has this trapezoidal shape as well. And Premier were also kind of famous for their strange paint schemes on their chassis, as also on their control panels. They had really colorful control panels. The parent company for Premier was Multivox, and these were all made in New York City. Here's another Premier. You can see again the trapezoidal front, and here's yet another one with a trapezoidal front, and another still with the trapezoidal front. So we've established that these Premier amplifiers had an affinity for this trapezoidal grill. But yes, absolutely, the bell has come off of the Jensen in shipping. Okay, that is a Weber speaker actually, not a Jensen. But the bell has come loose from it. I need that bell right there for one of my restorations. This looks like it's had a lot of repairs and stuff in the past, mostly through a guitar center in Arizona by the look of it. So, you know, we've had a lot of repairs probably to contend with. We'll have to look and see what other techs have done before us, which is always fun. But yeah, we got some tubes, we've got a speaker bell to put back on, and we'll take this thing in and give it a little closer look. Okay, so I'm here with this amp on the bench, and I've been playing it for a little while, and I don't see what he's talking about in terms of the crackling. So that leads me to believe that it probably was a tube issue, like a dirty socket or something like that, because he had pulled all the tubes out for shipping and put them in boxes, and I put them back in, and when I did, you know, I kind of wiggled them and stuff and put them in, and so I would say that probably may have taken care of whatever crackling he was talking about, but I just don't hear a single thing as far as any crackling. As a matter of fact, this thing sounds really nice. Like I said, maybe it was something to do with tubes, but the crackling is gone. I will continue to monitor that and see, you know, if it comes back. But for now, we're just going to consider it gone. But intermittent problems, man, are some of the hardest to try to troubleshoot. And this might be a case where I just, you know, if it doesn't repeat it on the bench with me in front of it, then there's not a whole lot I can do. You know, I'll go through with a chopstick too and wiggle some stuff a little later on when we get it open and see if I can make it happen. But short of that, you know, I mean, the crackling issue, I just don't see it. I do see it maybe where it's a slight bit noisy when you crank it all the way. I don't know if you're gonna be able to hear it at this volume level, but you know, maybe a little bit, but it's not excessive for an amp of this type and of this age. It's just, you know, there may be something I can do. If each of the tube sockets is grounded the way that they are on Fenders, if the filaments are all grounded at different points along the chassis, it may be something that we can do to mitigate some hum by doing that, and maybe moving some things around and addressing some lead dress issues perhaps. But we'll get it open and see what can be done about what little hum there is, but it's not excessive, and from what I can see, this thing is really cool. This is a great amp. I'm really impressed. You know, a lot of people online have been comparing this to Fender Tremoluxes, and it just so happens I now have a Tremolux that we're going to restore at some point, so definitely subscribe and stay tuned to see that later on. But this will be a preview, a prologue to that, in that this is, you know, Tremolux-like. Tremolo works great. I mean, everything works fantastic on this right now. Dream, dream, dream when I want you in my arms, when I want you, and all your charms whenever. Okay, so apparently he said this thing has been worked on by about 3 different people since he's had it, or poked around inside of. He said poked around in. I think were his words. This Weber speaker, we already talked about that. This bell had come off and was rattling around in here, but I couldn't see any damage that was done or anything, luckily. So, okay, so we've got a bunch of new capacitors over here. In fact, it looks like every capacitor over here has been replaced. This one, there's a replaced resistor hiding back in there, replaced. Yeah, all the capacitors here have been replaced. There's another power resistor, I presume, or maybe, no, that would be a bias resistor right there, and this is probably a bias resistor as well over here that's been replaced. So there's a can capacitor down in here underneath all this mess that's out here. It looks like maybe they tacked in some new capacitors just across whatever's in the can, which is improper. That's not the way to do that. So we will certainly redo that, even though it sounds pretty good. Maybe that's contributing to the slight buzz that I hear. Again, it's not excessive, but it is present, and maybe that would get rid of this mess, and replacing that with something a little bit better done would help, and we wouldn't have caps tacked across other caps. But also, I don't see a virtual center tap. Or maybe I do. Yes, I do. Yeah, there's a virtual center tap in here already. It's right, I think that's it right there. See these 2 resistors sticking up? So that's probably a virtual center tap. So they've already done that. But yeah, pretty much everything else in this has been serviced to a pretty decent standard. I mean, the work all looks pretty good from where I'm standing. Not that things can't be improved, but he also wanted a mod done to this. He wants an effects loop. Originally, he wanted an active effects loop to be installed down here. The problem is the active effects loops that you find online that are you know, kind of an all-in-one product that's ready-made that you can buy. There are a couple different companies that make those. You can get them from Metropolis amps. You can also get them, or used to be able to get them, from Jet City, I believe. But the problem with those is they're about 3.5 inches wide, and it won't fit this way or this way right here. It's just not nearly enough room right there. So I told him about this, and I said I could still install a passive loop if you want, and then you can just use like an outboard buffer pedal if you want to, or maybe even just use a boost pedal or something like that in line with your send and return. And he's okay with that, so we're going to go forward with that idea. And I think also what we're going to do, I'll take a look at the schematic here with you, and we'll discuss some of the options of what we can do. This thing has 4 inputs, so we're going to requisition 2 of these for the loop. Probably these last 2 over here would make more sense to me, because what I think I would like to do here is install a switch, and what this switch will end up doing is making it so that you can parallel channels 1 and 2. I haven't really decided yet whether you want to switch between 2 different channels or parallel those channels, which was going to give you basically a gain boost. I think that's probably the way to go with this, because it would give you really the most versatility, and it's possible maybe we could even make that foot switchable. I'll have to look into what we can do with that, but we do have some room, like I said, down here on the back of the chassis, so maybe we could make that foot switchable in addition to being switchable up here on the chassis. But it's something to think about. Well, I'll ponder over it, and maybe we'll talk to him and see what he thinks about that idea. I think originally he had wanted to do like you know, two different channels and then the effects loop, but to me it just makes more sense. Because, you know, how many times do you actually use 2 different inputs on a guitar amp? I mean, you could use one and then go switch to the other, but the thing is, this has tremolo on both channels anyway, so it's not like you're going to get big differences like with a Fender or something, unless you did something to it. And I think the thing to do to it would be to parallel those first two stages. And I'll show you what I mean on the schematic. We'll take a look at the schematic here. Here we are with a schematic for this amp. This is a schematic for the model 66J. It's not easy to read. I cleaned this up in Photoshop as much as I could. I, grayscaled it and did what I could to make it look a little more presentable on camera. But forgive me if it's not still that good looking. But you can kind of see here we have a mic and accordion input. The mic and accordion input goes to 1/2 of a 12AX7 right here. The signal comes out of that and then comes down here through a coupling cap to a volume control and then on to tone stack before going eventually making its way. I can't see how it does it right now, but it comes out here and makes its way out to the phase inverter through here. Okay, so that's that channel. The instruments have 1, 2, 3 inputs for the instrument channel. All of those inputs go to this second half of the 12AX7 right here. So right away we can see that we have 1, 2, 3 too many inputs for a modern amplifier. You don't need 4 inputs because you only have one instrument. Nobody's going to be putting multiple instruments in. The only time you might need even 2 inputs is if you wanted to use like an ABY pedal and switch between one channel and the other. But I think this solution that I've come up with is a more versatile solution, and it's going to offer the most for anybody who owns this amp in the most situations. So here's what I've come up with. So when you plug into the microphone channel, that'll be the only input on the amp. It'll go through the 12AX7, it'll come down here, and you can see after this volume control, it's actually a little bit easier to see on a different schematic. So this schematic is for a Guild Model 99J, which is very similar, but it has 6L6 output and a 5AR4 rectifier. That's something we'll also do for this one. We will change the 5Y3 to a 5AR4 to squeeze a little bit more juice out of it. We'll have to check some voltages and check the bias on the 6V6 output tubes, but that should be fine. A little bit of adjustment to accommodate for any over voltages should be fine. You're going to get more oomph out of the amp if we go with a 5AR4. So we're going to replace it to a 5AR4 rectifier anyway. But you can see on the inputs, it's a little more clear on this schematic. Now there are some values. You can't really see the values anyway, but you can at least see the schematic a little better. It's laid out more intuitively. I don't know what's up with some amp manufacturers back in the day, man. They just really couldn't get their schematic game together. But anyway, so what's going to happen here on the new version of the amp is you'll plug into the mic input. It'll go to a first gain stage. Then it'll go through the coupling capacitor, through a volume, okay? And instead of getting mixed in after this gain stage, we're going to take this and we're going to sever this tie right here. Instead of mixing it here, we're going to tie it in back over here to the grid of this tube, and we're just going to eliminate all of these. And we're going to use 2 of these jacks in the effects loop, and we're going to turn one of these jacks into a switch so we can make this switchable. So, in other words, instead of just straight up severing this line, we're going to put a switch right here. And when you switch it, you can send either the signal over here, where it will come through and get mixed back in through a second gain stage, or you can switch it so that the amp is in stock form and it just gets mixed right here and goes on out. So that's going to give you a kind of the best of both worlds, in my opinion. It's going to give you the option of having the amp stock, and it'll sound exactly like it did when it was sent to me. And then you'll have, when you flip that switch though, it's basically going to go into beast mode, and you'll get 1, 2 gain stages before the tone stack and then the phase inverter. So I think this is going to be the best of both worlds. Okay, so I'm part of the way through disassembling all of this mess over here, and I just kind of wanted to get a record of where everything is. Yeah, all of this stuff was attached just right on the existing caps, so I just want to get a record of this can So we've got the half moon here with what looks like that's where the rectifier is coming in. This right here would be the main reservoir node right here. So this was on that point. This was to ground this resistor down here. That of course is the output bias resistor. So that just will go to ground. I think I'm going to go ahead and probably order another cap for this, another cap can, and do this properly. The other way would be to construct a couple of terminals over here. Remove this can and do a couple of terminals. I'll consider possibly doing it that way too. I haven't quite decided, but for right now at least, I'm thinking about just ordering a can and being done with it, because it'll be much neater and more in keeping with what it was originally. I mean, this is a really nice vintage amp, and I hate for it to be in this kind of state, especially with the way that all this was. And I'm sure that probably was contributing to some noise. Just a really quick note here. I have to say I really like the way that this is put together. I need to take the chassis out so that I can get this thing out. And I noticed that there are some blocks of wood back behind here to which the chassis is screwed here. It's also screwed up top. So there are 1, 2, 3 screws on each side, which is really good. And this thing is, as a result, it's very solid in here. So you're not going to get a lot of the rattling that you might get with some chassis that are just hanging. On this, it's all plywood. The baffle's plywood. Everything's really well made. The baffle comes out. The whole baffle will come out if you need it to. So yeah, just really well put together. Also, I can see in here that somebody has modified the filament circuit at some point. You can see pin 9 right here. All this wire is new. It's jumping over pin 9, pin 9, pin 9, all the way over to here. And then they've got the virtual center tap right here, which is probably not where I would put it, right on top of that tube. I would probably move it up here to the lamp and come off the lamp. And then there's a convenient ground right over here. So I'll probably move this virtual center tap over here, just where it looks better and makes a little more sense. And it's, at the end of the chain. But where it is right now, you could see the rivets where the sockets are held in. Well, they used to each one of these rivets had a tab on it that went to ground, that was used for grounding the pin 9 right there. So somebody has taken the trouble to sever that ground and to rewire the filament. But what they did not do is they did not run the wire around the socket and twist with the other filament wire and shove it back into the corner to try to get as low noise as possible. But instead what you've got is 2 filament wires basically surrounding the entire chassis. So, everything is in the middle of that field that's being sort of set up, at least in theory. Now, some people have different ideas on that, and you'll hear different people say it matters a lot, and other people say it doesn't matter. I've had experiences where I've rewound filament wires, and it's really hard. It's a hard thing to kind of A/B, because you would have to do it without touching any controls, and then test it immediately afterwards, and with the same conditions and all that kind of stuff. So it's a hard thing to test. Maybe and also it's hard to get stuff sensitive enough to sort of see the noise. I mean, you could hook it up to a scope and then test and check the hum then, and that's possible. But I think the thing to do here for sure is to wrap these filament wires and get them shoved back into the corner away from everything. The other way to do it would be to come out here on the edge and to wrap them up and then come down to the socket. If we wanted to do that, we could do that. But I think the thing to do would be to shove it back into the corner. So we're going to see if we can lower some noise by doing that. I also went ahead and pulled the cap can out, and the thing I found is this was a new cap can. So that was interesting to me. this is a new CE manufacturing cap can with a 40-40-20-20. The schematic calls for a 30-30-20-20, and they had all of these just tacked into each section, so they were paralleling in another 50 microfarads right there, or 47 microfarads on that first node, and then they had tacked in an additional 33 microfarads on the second node, and then on the third node they had a 22 microfarad tacked in. So they were really, I think they were choking this thing down, and it's just too much filtering. So we're going to eliminate all that crap, and we're going to put this back in. I pulled this out to see if it was the original cap can, and it turned out it had this label on it, so it's clearly not. So we're just going to use this instead of all that crap, and that'll look a lot cleaner over here anyway. And I think in combination with the with winding those filaments and moving that virtual center tap, maybe that'll clean up some of the noise, and we'll see maybe if there are other ways that we can do that too. We'll check the tubes and see if maybe some of the preamp tubes are noisy. It really wasn't excessive anyway, but I'm just going to do my best and try to get it the hum as low as possible while I have it. So yeah, that's essentially the game plan. So let's get started. We'll bust out the soldering iron now. Do you guys like my new soldering iron set up over here? Look, I've got my soldering gun. The reason I'm using the gun right now is because I've found that on stuff that doesn't require a great deal of precision, this is much easier and more convenient. And I just have this soup can screwed down to the edge of my desk so I can just stick it in there. So I'm not constantly hitting it or burning anything or starting fires. So I think that's pretty cool, right? You like that? Jerry rigging at its best, folks. You've got to think outside the box sometimes. Okay, so I'm getting all this wired back in over here, and previously they had this brown wire right here tied to this node. And if we were to look at the schematic, I mean, as you would suspect, you have one node that goes to center tap of the output transformer. You have a dropping resistor, node number 2, which goes to the screens. Okay, and then you've got, come over here and you have another dropping resistor. Then you have node number 3 with a 20 microfarad capacitor, which feeds the plate resistors for the first 12AX7. Okay, so and then you have another dropping resistor and another node that feeds the plates for the tremolo tube and also for the phase inverter. So you've got 4 nodes here. Well, they were actually using this 500 and whatever it is, 525 volt capacitor that's right here. This wire goes here to the cathode of the output. So they were using that as the cathode bypass capacitor, and there is no 4th node. They're asking that 3rd node to do too much. I think they've got too much on it. So I'm going to bust this out, put another dropping resistor, use this node as intended for the phase inverter tube and the tremolo circuit, and then we'll come up with something different for the cathode bypass capacitor on the output. I don't know if this is something that was modded at the time that somebody serviced it, or if that was like that from the factory, but I definitely think that this thing would be quieter with that 4th node. Okay, so currently this green wire that's taken off from node number 3 is going over here, and I think it's going right here. No? Where's it going then? Wait, I just got a bad connection. Okay, it's not going there, so it's got to be going there. Where else would it be going? Well, it's almost got to be going one of these two places because there's nowhere else for it to go. Because that's the... be there? There it is. So it's going to here, and we've got 1, 2 plate resistors here. Well, that takes care of the first tube. What about the rest of these preamp tubes? What are they doing with that? Okay, so let's talk plate resistors for a second. So that green wire is coming to here from node number 3, ends up right there. And you have 1, 2 plate resistors that feed this tube down here. So node number 2 is coming to here, and it's got 1, 2, 3 plate resistors right there. So these two right here are the phase inverter plate resistors. So plate, plate, plate. One of the resistors needs to be split out and put on its own terminal. We've got an unused terminal right here, number 15. We'll probably split out the one that's going to the tremolo. We'll split that one out and put it over here on its own. It makes more sense to put the V1 tube at the complete end of the chain because by then it has the most possible filtering a little further down. So anyway, I'm gonna redo this and I'll figure it out as I go. But I definitely need to work on this, work on the power supply rail. Okay, it might seem a little bit crude to some, but I've marked this with an R for rectifier, P for power, and mark these also trim, phase inverter, and preamp. That way when you look in here, under here, and you're changing tubes or whatever, if you have all the tubes out, you know what goes where. You don't have to take the back door off or anything like that to refer to that. I wish more amp companies would do that, would clearly mark on the outside of the amp which tubes are what. It would make things a lot easier. Okay, so I think I figured out what I want to do here. So this green wire, which is node number 3, is coming over here to feed the V1 tube, which is the preamp tube. I want to move that. I don't want that right at that point of the stream. I want that further down. So I'm going to take that off of this node and I'm going to see if it'll stretch. Hopefully we've got enough room. I think it'll just reach. So I'm going to move that wire over to this node, and I'm going to run a new wire from here that is going to feed probably the trim. It's always a bit of a shame when you've just wired something up to have to undo it. But I just got to thinking, I was like, hey, why do they only have 2 dropping resistors here? And I was like, holy shit, they're missing an opportunity for more filtering. They added all those extra filter caps. And it was kind of a forest for the trees scenario. It looked like, you know, they added more filtering, but they were actually doing less filtering than if they just added another node. So, okay, let's see if we can get this green wire stretched over there. I don't want to have to change that wire. Okay, so we're gonna need a dropping resistor to come down to this node as well. And I'll probably just use a standard like a 10K. They've got one here that's a 22K. And that's a little bit larger than what you normally see. You usually see like an 10 to 18K, something like that. And usually, actually, this first node is oftentimes a little bigger as well. But they've got like a 470 ohm right here. The schematic calls for a 560 ohm, but you know, I mean, probably anywhere from there to a 1K is okay. I think you usually see about a 1K dropping resistor on the first node, between the nodes on a Fender stuff, and then you'll see 10Ks kind of down the stream. So we're just going to make a 10K right here and make that work. It doesn't have to be 2 watt, but we might just go ahead and make it 2 watt. Okay, that is much more like it. I keep forgetting I have these. I've got a whole bunch of these, and I believe this is all Teflon wire. Really nice. It's all pre-cut. It's already tinned on the ends and everything. I've got a whole bunch of it, and I keep forgetting that I have it because it's really useful. I wonder if I can even get this in the tube. that would be slick if I can get that in the tube. Oh, look at that. I even fed it into the tube. It's gonna look good. It's gonna look good. Gonna look real good.
Get in there nice and deep like.
Yeah. We'll use terminal number 15. 15. We're gonna use 15 over here. Y'all, we gonna be using 15. Actually, I want to go the other way because it makes more sense. And they've really got those twisted on there too. Yeah, I was afraid of that. I was really afraid of that. Shit. Well, that didn't work out. See, they had those physically hooked on there, wrapped all the way around the post, which is not a terrible idea, but it makes it really hard to, when you're trying to modify something or come back later and change a part. The thing is, too, the schematic is full of errors. I've noticed that the schematic on the trim circuit, like for instance, how is this plate of this tube getting any voltage? Because if you follow it, here's the speed control, but there's nowhere where it actually ties into the power rail. It's going to the grid of this tube, of this half of the tube, and this plate is getting voltage from this node on the power rail, but then it comes over here and feeds these tubes, and nothing is being fed up here. You can see it skips over that. So how is this getting any voltage? I mean, if you look at other Fenders and stuff, it's obvious the way that the trim is getting its both halves. Well, this one, for instance, this is the 99J, so this one is getting voltage clearly on both tubes. So here's a resistor here, so both of them are tied to the power rail here on this model, but on this one it's just full of errors, especially in the Tremolux circuit. Okay, so I have all this stuff wired up and fixed, and it's looking a hell of a lot better. I still have to do something about this bias resistor for the output and bypass capacitor, but we'll fix that in a little bit. Well, now we're going to address the problem with the filaments. And so the first things first, I'm going to remove all the filament wires that currently are in the amp, and I'm going to retwist and just redo them all, because this is a filament wire just hanging out here in space by itself, and then the other half of that pair is down here near the chassis. So the whole thing really needs to be done completely differently. And I think what I'm going to do on the filament wires, for this at least, I'm going to float these up over everything, and then for everything else, or I don't know, I might stick it down to the chassis if I can, but for everything else I'm going to hug the chassis here along the front lip. Okay, we're gonna go ahead and For the effects loop, I'm going to need at least one grounded jack because we need to pass signal through a grounded jack under normal circumstances, and then when it's plugged in, it needs to be engaged, the effects loop. So we're gonna, I think we're gonna put the switch right here, because when you have 3 plugs plugged in up here, or 3 cables rather, they're gonna kind of be, it's gonna kind of be a bit of a mess, and it might be hard to reach over easily and switch that unless it's right here next to the other controls. So we're gonna put that switch right here on the end. That was done there pretty good. Physical connections are good and all, but they sure make things hell whenever you're trying to get it all apart. That's why usually cutting stuff is the easiest, quickest way to get it off of here, but I don't always like doing that. It's when I'm going to reuse a part, because it's just easier to go ahead and get this stuff off of it. Ah, shit. Hell's no, fuck it. Yeah, I'm just gonna relieve this of all this crap. There we go. And we will figure that out. Okay, so it skipped forward just a little bit here. I've installed the switch that we're going to use here on number 4. So this is going to switch between our high gear and low gear, essentially, on the amp. So what we want to do is we want the first stage to remain the same in all cases, or in both cases, I should say. So coming out of the first volume, where it gets mixed in, here's where we want to sever and put our switch. Yeah, this is probably also where we are going to put our effects loop. Okay, so we need the effects loop first and then the switch afterwards. Okay, man, we are done with the mods on this, and I'm feeling pretty good about it. You plug into this jack right here. It goes through the first half of the preamp tube. Signal comes to here, which is the volume pot for that first channel. So this will now act as a gain control in your beast mode, which is what I'm calling this. So when it comes out of this pot, signal comes over here to the effects loop, where it will go through this out the send. Well, normally it won't do anything if it's not in use. It will just go to directly to the little shunt right there, and then directly to the tip, and then it'll come to this point. But if the effects loop is engaged and this is detached, then you will have, of course, your effects loop will be in use, and it'll come out of here and still go to the center right here of the switch. When it's in beast mode, it will come out of this side, and then this shielded cable leads to the second half of the preamp tube, goes through that, and then comes back out of here, and then goes on to everything else. So I think it's all correct, and yeah. Whenever this is switched in the other direction, it will come out of here and it will just go directly where it used to go, which is over to here and on out. So essentially it would be just normal So the everything is installed right here between these two volumes. So basically I severed this connection, installed my effects loop and my switch right here. And yeah, that's pretty much all there is to it. Modifying a Guild 66J. These modifications would also work well on a Tremolux type circuit. If you wanted to modify a Tremolux to be it's a very similar amplifier anyway. You can see here you've got these inputs that go to 1/2 of a 12AY in this case. And on this side, you've got another half. Okay, so that, and then they go to phase inverter and then out to some 6v6s. So a very similar circuit, not exactly the same. There are some key differences. The biasing, this is a fixed bias on this one. It's adjustable. I know that's confusing, but it's called a fixed bias circuit. And then on the other one, it's a cathode biased output. But they're very similar. I mean, you can see right here 25 microfarad, and this one's got a 1200 for the bias on that first stage, and the Tremolux. And also they're tied together on that that bias. Tremolux is similar values. It's not exactly the same, but similar. All right, we're gonna dial it up slowly on the variac at first because we did so many changes. I mean, you never know. I make mistakes. Everybody does, so. Whoops. It would help if we had a rectifier tube. That would help. Okay, let's try that again. And we do have filament, and filament. We've got lit filaments. Yep. Okay, so our filament job did well. Okay, our bias, I want to see what it is right now. So, it's moving around because of the, let's stabilize that. So, 0.029 times 230 volts, 6.67 watts. That's fine. We're going to go ahead and dial it up to 120. Okay, 120 volts in, 0.6 amps, so 600 milliamps, 66 watts of power overall, which is, it's about right for what you would expect, I think, for an amp like this. 0.037 times 279 plate volts equals 10.3. That's actually spot on. That's right at 10 watts. Let's plug in a guitar and see what it sounds like. Okay, so this is the normal mode right here. This is beast mode. Okay, it's going into oscillation, so we're gonna have to do something about that. The problem currently is that we need a grid stopping resistor into that second stage. We have nothing. Okay, we're almost done with this amp, and as is the case with most times you do modifications, there is a little bit of back and forth. You have to work some things out, and you'll see this little resistor down here and the red clips that I have going. The resistor is a bias resistor that I decided needed to be separated out for the second half of the second gain stage in the beast mode channel. Well, this when you ground this to one point over here, which is the most convenient place to ground it, I could ground it right here, or I could ground it up here to the input. If I ground it right here, we get a lot more noise. I noticed there was a bunch of noise going on, so let me turn up the volume controls. Let me back up so you can see what I'm doing. Okay, so I'm going to turn up the volume controls. You'll be able to hear the level of. I mean, there's some hum. It's not too bad, and that's cranked. That's, you know, I can crank the bass and it gets worse, but you can definitely see that there's some hum there. Well, listen to this when I ground it right here. So I'm just basically going to push this down to ground it here. See how much worse that gets when you ground it to right there? So ground is not ground in an amplifier. You have to pick and choose where you ground things, and there's a popular way of grounding. It's called star grounding. What you want to do is you want to make sure that the grounding flow goes in one direction and everything kind of converges at one point of the chassis. If you have a situation where you're grounding a channel in multiple spots, it needs to be done such that it follows a flow. Otherwise, you're going to get loops like that, and that's a pretty severe difference right there. And what's now, I don't know. I'm going to test this cap to make sure that the cap is all good. Maybe there's a reason. They probably encountered the same thing when they tacked all these extra capacitors on there. They thought they were doing it a favor, by trying to get more filtering going. I don't think it's that. I think it might be the way that this is fastened back here. It's not really fastened. The cap itself is vibrating a bit, and it's not really fastened in a great way. So I'm going to tighten down the fastening for the cap can a little bit better, and then we will ground this. We'll try to find the ideal spot to ground this, and I think it's probably going to be right there at the input. But we could test that out too. Let's see. Let's try it over here, for instance. Actually, that's less right there than it was before, or that's more severe. So put it back on standby, and we'll move it again. The reason I'm putting it on standby first is because I'm actually breaking the the bias, the cathode bias for that half of that tube. So I don't want to do that while the amp is. Well, there's voltage. Actually, that is more severe than that. So let's move it back to the input. We'll move it to right there again. That is reduced about as much as I am able to get it right there. And that's actually very nice. That's actually going to be good. And that's with the bass pretty far up as well. So that right there is going to be acceptable. And that's, I think, about as low as I'm going to get this noise without a choke on this amp. There's no choke. And it's from the 50s. It doesn't have the greatest layout to begin with, and without completely stripping and redesigning the amp and all of its grounding, putting some kind of ground bus in, that's going to take a lot of redesign, a lot of thought, and a lot of time and effort, and that's probably more than this customer is willing to pay. I would be willing to bet. So we're going to leave it at that. Okay, so poking around in this thing a little bit further, I have tightened up all of the bolts for the can capacitor. Those are tighter. Also, I added some tape on the outside of that can capacitor. And the reason for that is for dampening, because it seemed to be vibrating a little bit, and I wanted to dampen that down as much as possible physically. Physically dampening stuff is kind of important when you're talking about noise. The power transformer also, I tightened down all the bolts of the power transformer. They were all a little bit loose, so that I think that may help. Sometimes it does. Also, the point where the ground was connected, I made sure to really tighten that bolt down and cinch that right down to the chassis, because that's pretty important. That's where the virtual center tap is going. The virtual center tap could possibly be tied to the cathode of the output, and we may rethink that and do that. We'll see. if this continues. But I think I found what might be the #1 cause of a lot of the issues. And the thing is, when you add a gain stage to an amp like this, if there's any noise that's being introduced in the first gain stage, that's going to be amplified 100 times. So, you know, what might seem like a little bit of noise, a tiny negligible amount of noise, when you add a gain stage right after that noise, it can amplify that 100 times with a 12AX7. So I think that's what has happened in this instance, and I'll show you what I mean. If we look at the line that's coming in here, okay, it comes right over here to this grid. That's the first stage, right? But look at this. The shield for that wire is grounded right here, and if we look up here, it is also grounded. You can see it back here. You see that ground wire right in there? You see that braided wire that's coming over? It's grounded at both ends, which is a big no-no. When you do shielded wire, you ground it at one end or the other, and then you consistently do that throughout the build. In this case, they have it grounded at both ends. So any fields that are present, any kind of anything in between those two ground points is going to be introduced as a hum, and it's causing a ground loop. So I think by simply disconnecting this end and shrink tubing over that and then reconnecting it, that might fix 99% of the hum problems in this amp, and it probably has been a problem the whole time that this amp, you know, has existed, and no one has ever noticed it until now. So maybe, fingers crossed, this will make a big difference. One other thing that I did notice on the cabinet, I can't show you right now because the glue's drying, but one of the supports on the cabinet that holds the chassis in, where these two screws go over here, that support had come loose, and I had to shoot some glue down in there and clamp that back down. So once that dries, we'll be able to put the chassis back in and then give it a test. Okay, so we've reached that point in the video where we talk about all the changes that were made. You guys already know, of course, about all of this stuff over here, the cap can, and how they had all the other caps tacked onto that. So we removed all that stuff and got that all cleaned up. We did discover that the cap itself was physically vibrating. That could be something that we end up... I don't know. I don't think that that's the fault of the cap. The caps themselves test good. I don't know if it's a mechanical thing with the way that it's mounted, but I'm not sure that there's a better way to do it, regardless. But I tightened down all this stuff. The ground, the main ground is over here. Redid all the grounds. Actually added added a ground bus underneath. You can see this this wire that runs, it starts actually over here at the input and then runs up and around, connects here to this grounding point, up and around, and all of this stuff is now connected all the way down. So you don't have to rely just on the screw connections for the pots themselves. There's an actual bus there to make sure everything is properly grounded. Yeah, you saw the filaments where I redid all the filaments. There was just... you know, originally they were all tied to their own localized grounding point near the sockets, which is fine if you're not using, you know, a lot of gain. And an amp like this really doesn't have a whole lot of gain from the factory anyway. It's just basically, you know, one stage and then into a phase inverter to the output. So it's not, there's not a lot there from the factory, but you know, when you cascade those gains like that, you got to try to eliminate as much noise as humanly possible. And this was one way of trying to do that, was to twist all these wires and run everything through a virtual center tap. They already had a virtual center tap, but it was in a different location. I just moved it over here and grounded it where the main ground was, the one that we tightened down over here, to make sure it's nice and secure. Rebiased the first the stages. When I redesigned these first stages to be cascaded, I had to rebias them, so we had to decouple them. Their biasing was originally done together, so you can see the cathode here of this one, this channel, and the cathode of this channel. Both were tied to ground through a single bias resistor and capacitor, right? Bypass capacitor. So we broke those two out and changed it. So now I have a 0.68 and a 1500, and I have a 1500 on the other one with a 22, and that's on the second stage. I did have to put a grid stopper resistor on the input of 47K, which is basically what I call the Valco value. You see that value in Valcos. Fender usually use 68K, and it would go down to 34K if it was in parallel. But we're using the kind of the happy medium there. And it was really necessary too to kind of suppress some of the highs and the noise. It helps a little bit with the noise too. We have a 220K grid stopping resistor on the second stage going into that stage. I experimented with making that a larger also, but settled on 220K. The main thing, of course, that we did was the switching. Now we have two different modes on this amp. One of them is what I'm calling the normal mode here. So if it's in this position, it's in normal mode. If it's in this position, it's in beast mode. You plug into here, and you have two different modes. So if you're this switch will send the signal two different directions. So if it's in this mode, it just sends it on straight out through the tone stack into the output, just like it was originally. In beast mode, it takes that signal at that point and sends it back through a second stage, so that then you're able to use both of your volume controls, and then it goes on to the output, and you've got a lot more gain on tap, and we're going to demonstrate that here shortly. Right before the switch, we have a effects loop send and return. So, and the cool thing about this is you have different ways that you actually have three different modes on this amp, not just two. So you can plug into this and have this mode and this mode, or you can come over here and just plug right into the effects loop return, and then you'll be using the second volume control. So when you're plugged in here and you have it in normal mode, only this volume control is working in this channel. And it's actually biased different as well. So there is a smaller bypass capacitor on that first stage. So this is going to sound different plugging into here with normal mode and using this control than if you plug into right here and when you're in, when you're in beast mode up here and you're using this volume control, because there's a different capacitor on that. So it's going to be fatter going through here. So if you like a fatter, rounder sound, or if you have a Fender or something like that with single coil pickups and it sounds a bit thin when you're in this channel, put it over here and then turn this one all the way down and then use this channel when you're in beast mode, and then you will have a fatter tone. So anyway.